This last lesson is going to be talking about titrations and the calculations that we can do to figure out and solve for an unknown molarity. So the first thing is a titration it's a neutralization reaction, which we talked about in the last notes. Neutralization, of course, is the reaction of an acid with a base, and it's going to form a salt and water. But what a titration is it's a type of lab test that we can do where if we know the concentration of one of the components, whether it's the acid or the base, we can figure out what the concentration of the unknown acid or base is. So the first thing about a titration is you have to have a known concentration, and we call this a titrant. And it can be the acid or the base, just depending on what you're trying to find, but you have it in something called a burette, and we'll look at a picture of that in just a moment. But the titrant is got to have the known concentration, okay? And so it's added into the unknown concentration until it's neutralized. And then at that point we can do some calculations and figure out what the unknown concentration was. The end point of a titration is when the color changes, and that's something we talked about in the last lesson with indicators. We said phenolphthalein, methyl orange, we're going to do a titration with brome thymol blue. And what they do is at the end point they change colors. And it's very, very sensitive. One drop can make the difference in the end point change because at that point it's no longer the acid. We hit the end point, and then one drop past that, it's now, say, basic, and so the color would change. The equivalence point is actually when the neutralization, excuse me, I just spelled that wrong, equivalence. Okay, and that's when the actual chemical neutralization occurs, but we can't see it unless we happen to be doing that titration with the pH meter. And so the end point is literally one drop past that. But because one drop is only about 0.05 milliliters, it's close enough for our calculations. So just make sure you understand that there's a difference between the actual equivalence point and the end point. The end point is the visual representation of that equivalence point. Here are the steps in a titration that you can read through. One of the things that I'm going to want you guys to do before you actually do the titration is on Canvas. There is a video. It's actually a YouTube video about 6 minutes long, and it's showing the technique of titration, and it happens to be showing the technique of the titration with the acid and base and indicator that we're going to be using in the lab. So make sure you take a look at that before you come to lab. This is what the setup for a titration looks like. We talked a while ago about a burette. This is a burette. It happens to be a very accurate sense of measuring. It can deliver drop by drop, and the markings are very precise. It's one of the most precise in delivery systems there is. And of course we do the titration in the Erlenmeyer flask, and then you add indicator. So remember, the standardized solution, or we called that a titrant, was in the burette. So, how do we do the calculations? Remember when we were talking about a strong acid, strong base, complete neutralization occurs, and here is the simple or the net ionic equation that happens, and that's H plus OH yields H2O. Okay, so we are going to actually use this formula for calculating for titrations, and it should look vaguely familiar. MaVaNa is equal to MbVbNb, okay, where M is molarity, V is volume, and N is number of moles. Okay, but this time our number of moles is going to be a little different. The A and the B, of course, stands for acid and base, so this side is acid, this side is base. Okay, but Na is going to be moles of H, excuse me, in the acid. And Nb is going to be moles of hydroxide in the base. So we actually won't even need to look at the balanced equation. We're going to look at the formulas of the acid and the base that we're going to be doing. So let's work an example. And I don't know what happened when I was entering this in, but I totally changed magnesium to sodium, and that doesn't work. So we're going to change this side right here. So it's not going to make that, obviously. It's going to make magnesium chloride plus H2O. And then we don't have to balance it, but I can't move on without balancing because I just can't. So we're going to balance that, and I have 2 chlorine, so I'm going to need a 2 there. Then that gives me 2 plus 2 is 4 hydrogen, so I'm going to need a 2 there. But we're actually not going to even look at that. We're going to look at the fact that HCl in its formula has 1 hydrogen, so Na is going to be 1 mole of hydrogen, so that's going to be 1. For magnesium hydroxide, remember Nb is the number of hydroxide that are in the formula, so in that case Nb is going to be 2. So now we can work our problem using our Ma, Va, Na equal to Mb, Vb, Nb. Okay? So we have 20 mils of magnesium hydroxide at that concentration, and we titrate it, and we see that it took 10 milliliters of our unknown acid, and we want to solve for the molarity of the acid, so that's what we're going to be looking for. So we're going to be solving for Ma. So we're going to rearrange, and we're going to say Mb, Vb, Nb over, Va, Na. So now we plug in the molarity of our base, 0.0050 M, times our volume of 20 milliliters, times our NB, which was 2. And then we're going to divide by the volume, which was 10 milliliters, and then our Na, which was 1. Now, because we have milliliters on the top and bottom, we can actually leave our volumes in milliliters. We do not need to cancel them. We don't need to convert them to liters because they're going to cancel out anyway. So when we do that calculation, we're going to get our answer for our molarity in 2 significant figures, because if we look back in the problem, it has 2 significant figures. So our answer would be 0.020 molar HCl. Okay? And you do have some left side activities that you should try to work and see if you can use those formulas and get the correct answers. The left side activities do have the answers there, so you'll know if you do it correctly. Okay? And that ends this lesson and the notes for this unit.